Hey guys, welcome back from Classic Work. 2 years ago I made a video that I named The Basics on a Speed Square, and it just broke 1 million views here within the last month. And I had no idea when I made this video that it would become so popular. So I had a guy write a comment not too long ago that he had gotten a metric speed square and that the numbers on his didn't match up with mine. And I did not know that Swanson had made a metric speed square, so I went and bought one, and I decided to do a tutorial on the basics on the metric speed square. We'll go into a little bit more detail than I did on the standard. So let's jump right in and get started. One thing is that you can tell that the metric one is a good bit bigger than the standard one. It's not quite as big as the Big 12 that Swanson makes, but it's in between it. But anyways, we'll go over some of the simple stuff first. Since it's a square, it's made to bump up to the edge of a workpiece and scribe lines very, very efficiently and accurately. So first thing is you can bump it up to the edge of a piece and scribe a 90-degree line really quickly. The other thing is you can use the 45-degree leg on it. Just bump it up to the edge and scribe a 45 off of one edge. Now it's the same as the standard. Everything about it is the same. The degrees and everything are all the same on the metric. None of that has changed. The other cool thing on the metric one here is it's got this large ripper slot in it, so you can pick between 2 and looks like 14 centimeters to rip a board. So you can stick this on the board. Say we wanted to rip 5 centimeters, you can hold your pencil in that slot and drag the square down, and you'd have a 5 centimeter line from this side of the edge. The other thing on here is it has a protractor just like the standard, and all of the degrees are the same. To use the protractor, all speed squares have a pivot marked up here on the top edge of the corner, or the 90-degree corner on the square. So to use it, just bump it up like you would normally, and then you're going to pivot the square. And all you have to do is read on this side of the square what degree that you want it to. And you just put that line right on the edge of the board. So I'm going to draw a 45 because I'm going to draw parallel to this one. And you'll draw on this side of the square, not this side. Just remember that. So up there where the pivot is where you always draw from. And as you can tell, we've got a nice parallel set of lines here. And that is pretty much all the basic stuff about a speed square. The next thing I'm going to talk about is what all of these numbers mean up here. The next thing I'm going to talk about is these numbers right here, common and the hip and valley markers. Now, what these numbers were designed to do when Mr. Albert invented the speed square back in 1925 was to figure out the angular pitch of a roof. So, and if you can tell, I'm using the standard one here because the numbers are blacked in, you can see them a whole lot better. But what they were designed for was the ratio of a roof was 12 inches for the run and whatever number the rise was set on. So that was the standard on the commons at least. The commons were 12 inches on run always. So if you come over here, you can read this 1. So it'd be 1 and 12, 2 and 12, 3 and 12, 4 and 12, and so on as it goes up. The hip and the valleys were set at a different ratio. They were set at 17 versus 12. So if you come over here, it was 1 and 17, 2 and 17, 3, 4, and so on. So you had to get both of those ratios right in order to build the roof. So that was the standard one. The metric one is a little bit different. Since we're not using inches, we're using decimeters or meters. These are divided up in meters of run, or 10 decimeters per run. I know that's a little bit confusing, but as I go through it, it'll make sense. So the common over here, if you can, I'm sorry, the reflection's kind of bad. But the common over here was set at 10 decimeters for the run. So if you come back here once again, you have 1 and 10, 2 and 10, 3 and 10, 4 and 10, and so on. The hip and valley, like I said before, if you can read it right here, was set at a different ratio. They were set at 14 instead of 17 like the standard. So over here it'd be 1 and 14, 2 and 14, 3 and 14, 4 and 14, and so on, all the way to 30. So that's the ratio that you have to kind of keep up with in order for all this to work. Next, I'm going to show you all some of the basic layout that you'll have on a rafter and what you'll do and what you'll cut and everything. So let's take a look at that. Okay, we're going to lay out a common rafter now. Now, I've decided for the pitch on this one, we're going to take it at 6 and 10 on the metric speed square here. So the first thing you're going to do is come up to the edge of your rafter, and we're going to lay out what's known as the plumb cut. So put your pivot right here on the corner and take your common line here and put it right on the 6. Take the 6 and put it right on the edge of the board. Then you'll draw a line, and that'll be your plumb cut. Now from there, take a tape measure, come up from the edge of that board, and come down. We're going to go 50 centimeters on this one. Make a mark. Extend that line a tiny bit so you can get an accurate reading off the edge. Okay. Now you're going to pivot the square again back to 6 and 10. So we'll go 6, just like that. We're going to draw another line now. If you'll notice, both of these are parallel to our ridge plumb cut up here. Okay, now we're going to take our tape and come up from the bottom. This here's the bottom. We're going to come up, say, we'll say 5 centimeters. Whoops. Now you can play with this number a little bit. Depending on what code that you're using, it may differ. So put a mark right there. Then we're going to take another square here. You can use a speed square if this seems to be a little more accurate. And you're just going to draw a 90-degree line off of that edge. And this right here will be your bird's mouth. This here will be your waste material. So that's all the layout for the bird's mouth and the ridge up here. Let's say you're going to put some fascia on the end of this. So from your line right here for your bird's mouth, let's come down, let's say 10 centimeters. It's about right there. Okay. You'll use your square once again. Now, if you have this problem, as you can tell, I don't have enough board here. I can't read to see what it is. So what you can do is actually flip your square around and use the other end of the board to make your 6 and 10 once again. There you go. And there's your fascia plumb cut. And depends on how you're going to put your soffit in here. This here is not a big enough piece of material to do an actual soffit line. But if you were going to do one, you could take your square back. And like I said before, this material is not big enough. But we can see how it's going to look. Come in here, make a 90-degree line. And there you go. This right here is your waste material as well, all this. Okay, and as you can see, you have your fascia plumb cut with your soffit undercut, bird's mouth, ridge cut. Now, granted, I left out a very important step, which is doing all the math to determine that, but I've got other videos on that. If you want to check them out, I'll put them in the link below, and you can learn how to do that. But this is just an idea to get you your cut basis on what you need to look for. And that's what you want to look like. This here's our wall plate, and you can see that our fascia and soffit cut where they need to be, and you can also see the plumb cut. So now, if you do not know the pitch of the roof that you're fooling with, here's a real cool trick, because you have to know the pitch of the roof in order for this to work. So take you a torpedo level and come up on the rafter and draw a plumb line. After you draw your plumb line, you take your square, put it up on the rafter, just like you did to lay it out, and stick your pivot in flush with your line, and you'll come back here and look and see if the common fits through one of the numbers. And sometimes if they're not exactly level, it won't be exact, as you can tell here, but it's pretty close, and you can tell that that is definitely a 6 and 10 pitch. Well guys, I hope you got something out of it and hope you enjoyed it. It's a good tool to have. I imagine I won't use it very much because I don't use metric very much, just in my videos, but for all the other people out there that use metric extensively, it's a good tool. So once again, hope you enjoyed it. I hope you got something out of it. Y'all take care. From Classic Work.